This is the water refill section of my coffee machine, and snap this bit off. I've tried super gluing that together a few times, but it just keeps snapping, so I'm going to try and 3D print a new one. The water container comes off, so it's relatively easy to get to, but somewhat difficult to get out. So I might need some tools here. So this one, along with the rest of the machine, seems fine, so there's no need to replace that one. So I guess if I snap this one off, and when it's finished 3D printing, I'll just heat that metal rod up and push it through. So maybe the best way to get that one off is to heat it up as well. Oh, look at that, brilliant. So next step is to take some measurements to work out exactly what size it needs to be. So once I think I've got enough dimensions there to get started, I've opened OnShape. This is the 3D CAD software that I use. I won't go into too much detail of exactly what I've done here. There's a lot of videos on YouTube on how to use OnShape. There's one guy, TeachingTech. He's an Australian YouTuber, and I think most of what I've learned about OnShape I've learned from him, and also OnShape have some useful information attached to this program that you can go in and find. So it's pretty much done there, and just added some bevels just to make it look a bit prettier. Not that you'll ever see it. And then export it as an STL file. And you can see here as I'm editing, that entire process took about 20 minutes or so it wasn't too bad. Depends how much you value your time. So I use Cura to enable that to be 3D printed. And I have a preset ASA setting there, so I've decided to print it out of ASA because it's a bit more heat resistant. I don't think it's going to get all that hot there, but I thought PLA may warp a little bit. And so we'll need to print this with support, as you can see there. And I'm printing this in the direction I'm printing it so that the obviously 3D printer lays down things horizontally. So there will be some weaknesses just on that spot that I've got at the top there, but the shaft that broke originally should be in its strongest orientation there. So just realizing there I need to put support under that little overhang on the top as well, so that's gone in there now. So I use Polylite ASA. As I said, ASA I've used outside. It's UV stable, it's more heat resistant than a lot of other plastics. It does warp quite easily when you're on the bed, but this is a very small part, so it shouldn't be too much of a problem. So I normally heat the bed to 100 degrees for the first layer, and then it goes down to 80 for subsequent layers. So this bit's in real time just to remind people how slow 3D printing is. This took about half an hour all up. here's the finished product. Let's go and test it out. So I got it off without breaking it, and now I just need to remove the support material. ASA support material is not always easy to get off. Actually, wasn't too bad. And just these little pieces. Maybe a fork. Oh, there we go. So, doesn't look too bad. So the hole in the middle there is a lot smaller, which was part of the plan. So my concerns with this one, the weaknesses is probably going to be in here because I've printed the lines this way. And I did that because that's going to give more strength where this one broke. So that is, I guess, one downside to 3D printing, that you always have to compromise somewhere. So dimensions wise, it's not looking too bad. So I'm going to melt the metal bar back into this end. So really the important dimension is this one. So let's see how that fits in. Ooh. I like that. So before I melt it, I just do a test fit that that is correct and it's going to go in the right way. Pretty sure that's right. So I'm going to need to get the angle exactly right when I heat it up. Like that. And I need to be able to push that in without it twisting too much. Guess we just give it a go. Just hold that there while it dries. It's come all the way to the end, so I'm pretty sure that's the right spot. I cooled it down under the tap after I burnt myself. So let's try and pop that back in. Oh, got it. After a bit of fiddling to try and get it back in, the lid kept popping off. I can see now that the bump on the back of that one is actually quite significant. So when you close the lid, that's getting in the way at the moment. So I guess the options are I can just try and smooth that off, or if that doesn't work, I'll have to reprint it. So you might be able to see a bit better now. So that's the original one. This is the printed one. This little bump on the back is a bit too high and hits on the lid. So luckily ASA sands quite easily. So now I found my Dremel. Let's try and take a little bit off. I'm going to try that. So let's try that back in. Seems to work. I just went back to Cura to see how much filament I used, and it was 5 grams. So in Australia, it's $40 for 1 kilogram of ASA. So this project cost about 20 cents in plastic. So I'll be honest here. I reckon I've made this one 1 millimetre too long, or 0.5 millimetre too long even. So when it closes, there is a tiny gap there, but I think for the time it takes, even though it was cheap to make, I think for the time it takes, and I'd need to go back and edit the file, I could live with that. So that's a 20-cent fix. Wasn't an expensive coffee machine, but you know, today we're best to try and keep things as long as we can, be more sustainable. So I think, say, a 3D printer is a worthwhile thing to have. I'm gonna make myself a coffee. After I rinse the plastic dust out of there, that is. Thanks for watching. If you enjoy these types of videos, please like and subscribe. If you've got any comments on how I could have done things better or experiences you've had yourself, put them in the comments below. Thanks for watching, and I'll see you in the next video.